We have an exciting educational session, which is on the topic of requirements for apparel 3D body processing. So for the speakers, we have Katy Schildmeyer. She's an apparel technical designer and pattern maker at Design Cycle Solutions. And then we also have Carol McDonald, who is the chair of IEEE 3D Body Processing Group, P3141. And she's also the founder of Gneis Concept.
Katy and I are working together on IEEE P3141 and then also the industry connections side, just an FYI. So you can switch the slide. So the big thing is what is needed for apparel, avatars, and characters. So the important thing to realize is that they can be very different because in apparel, you're actually you have two main goals. One is to understand whether you can do fit for the consumer or whether you're letting them know what the style is appropriate for them. So fit generally has two components. One is, okay, I'm not in Japanese. Let me cancel this. Confirm your speaking language. Okay, so it's really confused. It thinks I'm speaking Japanese, but I'm going to change that. So just to go back on the use of apparel, apparel has two things for using, well, more than two, but avatars are apparel characters. One is to select the garment, one is to see if you like the look of it on you, and the other one is for actual fitting. So there's three main components, and you have to understand what's needed for each one to make sure that you're providing the consumer with the appropriate one. So part of the fundamental question for any of this is, what is posture? So everybody understands that you can tell the posture that's different from people. You know, if you've got grandma versus a 2-year-old, their posture is going to be very different. But what we haven't had before is how to actually describe that. So our group has come up with a paper on how to describe it. And that's the link that has been provided. And you can go to the IEEE 3DBP site and actually find that. And so it's very important to understand, if you want something to look aesthetically on people with different postures, you actually have to bring that into consideration when you're designing. So like I said, there's posture, there's unit of measure, there's location of measure, and there's also the fidelity or quality. So is the texture going to be correct? Is the position going to be correct? Is the movement going to be correct? And how does that natural posture or actual posture actually work? And so the other thing that we've standardized in is having terminology for the human, which is everybody on the call, a humanoid, which is a model of a human, a cover, which can be clothing, footwear, wearables, and if you have a model of that, it's called a coveroid. So we broke down the entire ecosystem into 4 main groups. And basically, you're either the actual item or you're a model of it. So one of the things, unit of measure, I think everybody understands. Is it millimeters? Is it whatever? The location of measure. Part of the big discussion is where is a person's waist? Where do you measure on the shoulders? How do you measure the hip? Is the hip really the hip, or is the hip really the seat? And where do you measure that? And the other thing is you've got these 2 objects here. They're both spherical in nature, but one clothing on the orange is going to be really baggy on the egg, and the egg's clothing you're really going to need a stretch fabric, and then it's really going to look ugly. So it's it's very, very different, and you want different garments for different shapes and sizes of people. And that you also have, there's conditions that impact that, aging, pregnancy, injuries, you name it. And so the other thing you have to add is when you're looking at aging or texture, you also have the texture of the person, which is the texture fidelity, but you also have the texture on the garments. You also have the light reflection. You have soft physics. You're just getting started on the garments to actually get all of those to drape properly in the digital world because of all the information that's actually required. Okay, I'm gonna let Katy go to this one.
Okay, so this is essentially when we take the avatar and we say, okay, does it have a unit of measure? Yes. Doesn't mean that it's a correct unit of measure, but there is a unit of measure. And is there a native posture? Now, current rig systems do not always allow us to address the native posture of a person. So the closest thing that we can come out with is a digital twin with some flaw in its mathematical metric aspect. Oh, it's doing the same thing to me, Carol. Excuse me. Okay. And conversely, we are dealing with trying to convey the truth of a fitting garment to a consumer. So this is showing basically a garment that we have put onto a size 6 and then onto a size 16. In that process, we wanted to convey how the truth of the actual person's body as it grows in mass can change how you evaluate buying or ordering a garment. And thereby, it changes the way the customer views the garment. So if the customer sees an actuality of something that is near the truth of their body mass, their body shape, their size, along with all the flaws that go with it, so stretch marks, textures, wrinkles, and those variables, they can make more accurate decisions. So the question is, what do you use in apparel to then create a better sell-through with lower return rates, because we're trying to reduce the waste since we're the second largest waste creator in the world, with 412 million units of garments being made daily. And or do we go with more of the AR VR option of saying we can create a beautiful avatar, we can dress it with whatever we want to dress it with in terms of artistry and imagination, but is it going to convey the reality of fit to the consumer, allowing them to make better choices down the line? So the diagram shows that there are places where we have the nose occurring in the value chain. And in that value chain, we can see that, again, we're dropping down to the digital twin or the AR VR person. And then the digital clone is really all about, you know, if a consumer was to actually get scanned in a booth scanner versus a mobile scan, so that we could, in fact, have a more accurate posture, unit of measurement, as well as gathering up some information about their fidelity, so their wrinkles, their skin tone, their skin color. And you can then also make better choices down the line as a result of having more accuracy in relation to the actual humanoid that wants to try on the coveroid. And off to the side, we have a little diagram of 3 different avatars. One was Mesh Capade, one was Clo 3D, and then another. And out of those, they all had a low success rate. So this slide is also showing how posture impacts pattern making. So if we have fit forms in the digital space that ineffectively don't give us correct posture that we can model, it will impact the actual pattern itself. So we have two models, two different postures, one where we've moved a garment, so the regular fit, onto a sway back, and we begin to see the makings of poor fit as it relates to one avatar versus the other with different standing posture that would be like a natural posture. And then the diagram beneath that is really showing the pattern itself and showing that our cut waist, if it's cut wrong and sold wrong, and we don't outline what fit this was made for, if it was a sway back or a barrel chest or a normal stance type of gentleman, we can end up with at least 5 inches of cut waist that didn't need to be cut. And then the consumer isn't getting the information that says, if you have a super erect stance, this jacket's made for you. If you have kind of a slumpy, rolled shoulder forward stance, we can suggest a different product for you. So the actual posture impacts every part of the garment from the neck down, as well as from the ankle up. So it's very important for us in the industry from an engineering perspective to deliver that. And then when we can layer in the artistry on top of it, as well as change skin tone and aging, we can actually create product that really meets consumers where they exist in real space and time in their present, rather than causing other issues. But yes, in terms of the 5 inches, that would be width and length in the cut waist. So in this area, this video was done by Obsess, and the link is in this slide, but the VR fitting using digital dress forms, this is one of the pathways forward that allows people to virtually try on garments, whether it be on a mannequin, which is great because it's non-descriptive. We don't have to deal with cancel culture. We can have various sizes in that mannequin come forward and allow the consumer to try those things on in terms of a styling perspective. But we do wish that there is a disclaimer there. It's very important that the customer understands that maybe this mannequin is a style-driven mannequin and it has no variable of fitting quality, meaning it's not the fit model base, and it's really just there for aesthetics that allow the consumer to understand that this is not the shape that it was made for. The other aspect is that if it was made for that shape and it's just a different size within that shape range, that's also outlined in the imaging on the website, or if it was an AI-driven model, because those have a tendency not to actually deliver real fit. So this is just the example of how we can take the apparel and apply it into a shopping environment that or a gaming environment that allows consumers to pick and choose what they wish. And of course, if you can meet the customer where they exist in their shape and size, it's all the better for transparency and sell-through of items.
So did you want me to cover this one?
Sure.
Okay, so what we found, and the reason why there's unit of measure, and the reason why we're trying to kind of put 2 layers of questioning, because you can say, oh, I have a AR, VR, I don't really care about the unit of measure, but I have these really great cosmetic features. And so the cosmetic features can actually be there if you have a unit of measure. It can be there if you have the native posture. And then you can actually be able to get into the digital clone, which is saying I'm within an accuracy of the certain measurements of the body based off of the day and the garments that the undergarments that they're wearing at the time. And so part of that is you actually have two work streams or data flows that are associated here. So if one just says, oh, well, I have these meters, or the unit of measure is meters. Well, that's awesome. Just let us know that's a yes. And then you can move on for your, cosmetic features. And then the question becomes, are you actually getting the actual posture of the person, their native posture, and whether you're picking that up or not. So a lot of programs will quote normalize it. Let me make you stand up straighter. Well, that might not be how I actually stand. And so therefore, if I'm making you a garment, it's not going to be appropriate. But let's say I'm using your character as a digital twin. I'm using you in a training video that, I'm training medical workers or any sort of training. That training doesn't need to have the same accuracy to a particular person as a digital twin. So it's really important to understand that you have a digital twin and a digital clone, and how they are very different, and how AR and VR can be very different as well. Like one of the things they'll do in AR is, oh, I just stretched the shoe to fit your foot. Well, that shoe may or may not actually be available in my size and width. So you've told me what I could get, but not what I can get. And it's very important that the consumer understands the difference, because it's only going to lead to more frustration if you're now dangling things out in front of me that says, oh, wouldn't these shoes look cute on you? And I go, yeah, well, I actually know that they are not available in my size, so why show them to me? So that's the key thing in here, is that we actually have two data flows and how to have them interact, because you can have artistry through all of it, and you can have a very nice mesh through all of it. You can have rigging through all of it, but how does that work with the actual humanoid and for your actual intent of the usage of this data at the end?
Mm-hmm.
Okay, so next slide. So
And this,
I think we've got it. Digital, humanoid. So it's a digital proxy. So we've got yeah, so multiple silhouettes. There's multiple ways of making the digital clone or the digital humanoid clone, and you have to get information from that data, or from the actual person themselves. ISO has a definition of digital twin and digital clone, and you can definitely read that, and it explains the difference between the two.
we
So
also have the
yes.
digital product passport, which is coming for pretty much anything that is being produced and sold through the EU as a waste initiative. And under that waste initiative for apparel is that some of that information, including the avatar information, so whether it's a humanoid, a twin, like a clone or a twin, will be very important. And as well as the sizing, shape derivatives of how you've gotten to that information will be also crucial, and that is also being embedded into the IEEE standard for metadata. So a lot of this information just needs to be tracked along its evolution and its humanoid to humanoid interactions as it goes from, let's say, a CGI range all the way down to a VR range. And that's really where fashion brands want to go, is they want to be able to take a high fidelity avatar and move it through the stages of the process into a VR space, whether it's video avatars or if it's in gaming, whatever that may be. They want to be able to move those products and the people through that system.
Yeah, so here's the twin, and actually it's not identical to the user. So that's really critical to understand, and that's really critical to let people know that, hey, it's your twin, it's not identical to you, it's close enough. The other thing that's very common now, especially with phone apps and things like that, is that people already have these models kind of in the background, right? I've already created this humanoid, and now I'm just going to alter the humanoid by saying, oh, make their waist a little bigger, make their chest a little different, or whatever. They don't do well on, let's actually change the height and tilt of the pelvic area, or the tilt of your back, or the curvature of your back. They tend to just say, oh, the only thing I'm going to do is make you a little taller, make your tummy a little bigger, but there's still a whole realm that the parametric humanoid needs to be able to do. A lot of times what they'll do is they'll say, oh, here's the rig. You can definitely move this person, but if you actually then go in and try to age the person, like I change my shoulder roll, I change how all of that rotation is happening, they really can't handle that. So they can handle certain things, but not really enough to actually get the model of the person, or to get that virtual twin closer than what they are doing now.
Yeah, and this becomes important when you're dealing with biomed devices in a soft goods apparel industry. If you're trying to create some sort of bracing mechanism to help somebody's posture or pain, as well as even footwear for somebody of that nature, you have to have more accuracy within that 3D capture in order to deliver a better molding process, even for the ability to work in 3D and deliver a molded product, such as a custom made brace from a 3D model. And if it's rigged with an SMPL model, or even a SKL, which is more updated model, it's still not delivering the posturing requirements that we need. So, and then the next slide is, I believe, the fidelity definition that we would like to share, and that covers a range of fidelity. And that's the faithfulness and accuracy. So what is the measure? What is the actual natural stance of that person? What is their, gathering information such as age, and using that in relationship to the truth of that person to deliver something. And the data fidelity refers to the accuracy of the data. So is your metadata tracking along information such as when the date of the scan was, what it was being used for, how was it taken, what was the lighting mechanism, calibration systems, things like that aid in that process, and that leads into the electronics. So what type of electronic was used to gather that information, and or create that information in an avatar space. And then fidelity of the artwork. So again, where did did the examples come from to utilize the artwork, because we have a lot of reface technologies that are used in the industry without permission, unfortunately. So they're taking models' faces without permission, using them to create their avatars. And unfortunately, they don't see that as being an infringement on the model's rights or income, in which case their face is actually a copyright. So those are aspects of fidelity that quite oftentimes get overlooked in the apparel industry. And I think that we're pretty much done. So we want to open it up for discussion and questions. And we also have a few questions of our own. So.
All right. Thank you, Katy and Carol. Great presentation. Appreciate sharing all your insights with our group. I do see some really interesting questions in the chat, so maybe we can start with that. Let's see. Yeah, John, do you want to kind of iterate any of the questions that's happening in the chat? Feel free to unmute your mic and ask.
Well, I'm interested in this from the standpoint of how do we do metaverse avatars? And I use Second Life and Open Simulator as a base. I'm running a new client for them. And that has a system with about 140 parameters for an avatar. I just put a message in chat showing what they are. So they already have a somewhat overkill parametric avatar. There's stuff there that you would never really bother with for clothing fit. I mean, you can change like finger diameters and things like that.
It depends. If you're making gloves, the answer is yes, you would. But anyway, to move on.
I have actually used Second Life, and it still fails to fit in relationship to the armpit, the spinal column curvature, the crotch point, and a few other variables that go with that. And that, like the ones that I build for other brands, quite honestly, have over 256 points of measure that I use, and over 300 nodes that I lay. So, and that is because we're tracking depth of body, we're tracking angles, arrays of the armpit, the crotch region, the neck, and it does have to have a unique structure applied to it in order for it to do what we need it to do. So that's just what I do with the apparel clients, because they literally will ask for some of the strangest measurements, but it's because we need it for pattern making.
Okay. Yeah, great question, John, and thank you, Katy, for information.
Yeah, but we've tested the Second Life ones.
All right. Yeah. Meanwhile, does anyone else have questions for Katy?
So I think he was also asking about very tight fit, non-stretch clothing. Is there a question about that?
Yeah, that's actually the harder. It's one of the harder. So it starts out and actually how to model items that are with stretch material. Because if you look at a lot of ISO standards, they'll explain about the gap that's between the clothing and the humanoid. What they don't have any reference to is called negative ease instead of positive ease, which means it's actually stretched. So think of your sock, right? It stretches to fit your foot. And so to actually model putting on a sock and having it stretch over your foot is actually it's actually a challenge to be able to do that. And like I said, it's the armpit and the crotch area, especially as bodies get larger. You have a lot of thigh touching at in the upper thighs, and so some of the issues we found is being able to tell the right leg from the left leg when you're getting closer to the crotch, and then in the armpit, how do you actually determine which is the body and which is the arm? It's much easier on the trimmer body or the smaller body, and what people have done is they go, oh, we'll start with the smaller body and work out, and actually what you need to do is start with the larger body, and it only gets easier the other direction.
Yeah, and the other key part of that is that Americans and Europeans, in large part, for men, the average waist size is between a 34 and a 37, 36, 37, which is a little bit on the larger size. And then for women, it's anywhere between a 14 to an 18 in both areas. And so we're seeing humans getting much bigger in their circumference. And if we're always working on a small body, it's not going to yield information that the consumer actually uses to understand the buying process. But I would also say, because I've had a lot of people also say, but I just want to use stretch in everything that I do. And the big issue with that is that a lot of clothes are not made with stretch. We've got jeans where consumers just want 100% cotton. So you really have to work with how fabric is used to enhance design and the artistry of design, in as much as using comfortable poly spandex materials, because those also go to landfill and they make up at least 70% of the fiber that's being found and burned in those landfills. So it goes directly to air pollution. And that's one thing that the industry is really trying to stop.
So we have somebody raise their hand.
Yeah, Jeff, yeah, go for it.
Yeah. Hey, y'all. Thanks for the presentation. This is a really fascinating use case. So I guess my question is, like, really, what's the next steps for this stuff? Like, do you guys have any recommendations for people to start adopting to make it easier to start building clothing to fit characters, or proposals for the avatar formats themselves that we can start integrating? What's next?
Well, we are working on a standard. In fact, very diligently this entire past week, I've been, I would say that the standard is next. I would also say understand what you have and how to model it, and how to, understand movement of larger bodies as well. And just, I don't know where your company is, but just things like, does your metadata tell the user what units of measure it's in? Yes or no, right? Do you give it a timestamp? Do you give it anything that says, oh, if I actually gave this to another program, are you right-handed or left-handed? Is Y up or Z up? Now, if you can answer those really basic questions in your metadata, I know if I can import that avatar into Rhino.
Yeah.
Simple thing like that. But, if it's Cinema 4D and it's left-handed, and my mesh is counterclockwise, and then it comes into Rhino and it's clockwise, and now I'm going to then import it over to H-Anim, and I'm going to do and then H-Anim has to go from an A pose to an I pose to get all their animations correct. Now that's what I'm doing with one poor little avatar. So I need to understand in your files that this is what I'm going to do. I need to program that in so that it says, oh, I can go from left hand to right hand without any problem. Now I can change all of my animations. So just think of it along the journey and what do you need along the journey?
Yeah.
It's not going to stay in whatever native file you put into it. Sorry,
Mhm.
dude, you got like
Mhm.
17 different files. So GLTF, we are working with them as well. Part of it is things like anchor points on a body. So they're starting out with shoes. We had to define the anchor point of the heel such that you know it's on the curvature of the heel and it's right on the bottom of the foot and it's in the center. But if you look at the ISO definition, it's not accurate enough to define where that anchor point is. You also have the back of the heel, but then you have shoes that don't have heel, that don't have back. So, oh, I need to know that it's here. And now I have to do clipping points. So you have to work with how the clothing actually is on that avatar as well. And so the answer is yes, we're working with them to standardize it. Yes, we're working with H&M to get the naming convention. Yes, we're doing the standard. So I think 2025 is going to be a huge year. You're just right before, but like I said, think about if whatever program you're in, could you send it to Katy and put it in Cinema 4D? Could you put it in Rhino? And how does that come all the way through?
Yeah.
And just work with, and you're like, and believe me, within about 5 minutes, you'll go, crap. Okay, now what do I need to do? And then you'll have much more understanding as to your program, your avatar will go through at least 3 different programs. Can it do the ride?
Yeah.
Yeah.
And
Interesting.
I would
Thanks.
say the other valuable thing to I think to consider as well is the render fidelity that comes out. So or the way it gets depicted. Also how the metaverse can maybe create some form of interoperability where, let's say I design my clothing on the fit model, right? But I maybe want something more aesthetic, but in the same shape as my initial fit body, right? How can I have some interaction with a metaverse tool that allows me to go from a fit model with the same shape? So whether it's like an OBJ convergence, right? Get that shape into place and then, lower the data computing power because we do take up a lot on our end just building, but lower it down, obviously, for the metaverse.
Put it on your phone.
And then allow that to have equal like image and texture fidelity, but low data computing and the ability to change the features and the looks of the base body in a way that works for the metaverse or metaverse tools. I would say that is a winning combination for anybody that wants to like bridge the gap between consumerism and the metaverse with apparel. For sure.
So you'll be busy. Just thought you'd like to know.
But you can also, we're always, we do look for people in the IEEE for like right now, a lot of it's shader information, things like that we're trying to get standards for.
Yeah, very cool. The stuff's really exciting. And it's, again, really cool to kind of see some of the convergence between like the CAD file formats and the real-time ones.
Yes, and they all have to agree and work together. So so like I said, just send that on through, figure out, get some and maybe even get, an apparel program and you have somebody in your that works with Clo or Browseware or some of the other ones. So yes, you can have a rigged mesh. However, some of the meshes can only handle certain number of nodes or certain number of joints in certain locations. And so what ends up happening is you can start Yeah, you don't run gaming physics. Yeah. So
Yeah.
it's part of the gaming physics, but I want to know how to drape. I want to do a catwalk. I want to put on a sock. I want to put on, jewelry. I want to have the earrings dangle appropriately while I'm doing a catwalk, and to make sure that my glasses don't, get embedded in my face, So just I mean, any scenario that you can think of, just play with it, and soon you'll go, oh, okay, I
Or
get
if
it. I
it's
get it now.
like if it's
Yeah,
apparel
yeah.
for tall women, right? Because I'm a tall woman, I always run a bend test on the garments that I make in there, because I don't want my skirt to flip up over the backside of my upper thighs and show my tush. So I really need to have the ability to have correct form and function in that respect, right? And so oftentimes that's overlooked, given that the average size of a fit model in female land is 5'6" or 5'5".
5 foot, yeah, or 5'8",
Yeah.
or yeah.
Yeah. So when you're taller, you do have to have different positions and pose checks that you would not use as much on a shorter body. And that's also for shorts. That's for pants in general, like the crotch. Nothing like getting a pair of pants that are too short there, and they kind of ride up in that whole area. It's integral to just general comfort and wellness and health in your daily life, but we also are really focused on trying to reduce what is produced poorly.
So here's the one, as John's saying, skirts do not map well to a rigged mesh.
No.
I would say a lot of us, a long skirt and a rig mesh is really hard. Exactly.
Yeah,
But,
it
if
is.
I'm going to go to a wedding, well, I went to the wedding, I did wear pants, but, the bride didn't wear pants. So, something, women wear a lot of skirts. So feel free to practice with the skirts, feel free to practice with the leg, and saying it's a rigged one, but how do I bring in so I don't have where that material can then interfere with that leg? How do you set up all those boundaries? How do you set it up so there's no collisions, or there, all of that, but so, but if you look at Chloe and Browseware, part of that is that they actually have a hard time with aging of the body as well. So they work really well for the under 40 crowd, but once you get to 80, the answer is no. So anyway, I guess we gotta go. So at least this was hopefully entertaining for your first morning meeting.
Yeah, thank you, Katie
Hopefully
and
we weren't
Katy.
all over the place.
Yeah.
Yeah. So yeah, just a reminder, we are towards the end of our meeting session. So happy to continue the conversation in water cooler, so folks who are interested can stay back.